Good afternoon, my name is Alla Kolstunova and I am an instructor at the CODDY School of Programming. And this is the first lesson of the Minecraft Introduction to Artificial Intelligence course. The topic of this lesson is algorithms. Our task is to introduce students not only to this topic, but also, since this is the first lesson, to familiarize them with the MakeCode environment where we will be creating programs, and to explain what the children will be learning in this course and the general structure of how the lessons will be conducted. So, as I already mentioned, the goal of this lesson is to introduce students to the Minecraft environment, to study the basic controls of MakeCode, where we will be creating programs, to introduce the concept of an algorithm, to learn how to complete simple tasks involving navigating corridors, which I will show in a moment, and to practice the skill of writing algorithms that will allow the agent, our robot executor, to pass through all the corridors we have prepared for it. So, as a result of this lesson, students will be able to explain what an algorithm is, and accordingly, if they can explain it, that means they have understood the topic and they have completed all the prepared tasks. But here, by the way, there might be a caveat. That is, if some students work more slowly, meaning they work at their own pace, of course, there is no need to rush them. Let them work, and if they complete at least 2 or even just 1 good task, and most importantly do it independently, that will already be a sign that they have understood the topic we are covering. There is definitely no need to pressure them to complete all the tasks presented here. So, since this is the first lesson, we need to greet the students, get acquainted, and give them a chance to tell a little about themselves. Again, there is no need to rush them. Let's spend a bit more time on this during the first lesson. But this will ensure that the students can work comfortably and communicate with each other, because we place a strong emphasis on collaborative project work and in general on working in teams on various tasks. So here you can see in detail once again what you can tell the children about this course, which topics we will be studying and how we will be studying them. Be sure to read this carefully so that you have something to say to the students. Although in general the students usually already know quite a lot about Minecraft, they have already completed a lot of different projects there, or at least have played the game. So maybe they will also share some useful information with you. So, the next step after the introduction is to present the topic that we are about to discuss. The topic is essentially about programming, and in order to recall all the information the students already have, which they usually do, since nowadays children interact with devices from an early age and generally understand what they are for. That's why it's essential to bring up this information, to engage even those who, for example, didn't come to this class of their own accord, but rather at their parents' insistence. So, in order to activate the knowledge they already have and to introduce the new topic, I suggest asking a few questions. If you have any other questions that you think are important to ask, be sure to add them to your lessons. So the first question I suggest asking the students is this: why should we even learn to program? In other words, how relevant do they think this skill is today? And the answers can be completely different. Some people say it's to create games, others already know that programming can be used to make all sorts of apps and websites. Again, the answers can be completely different. And to sum up, you can tell the kids that programming really does allow you to solve all kinds of problems nowadays. They can start with some really global issues that are solved in large corporations like Google, Yandex, or whatever else you can name. But even in everyday life, people can't get by without programmed devices or programmed gadgets anymore. So this is also something you should briefly tell the kids about. Next, based on the first question, you can thoughtfully suggest answering what, in our current environment or surroundings, is actually a programmed device. Things that surround us at home, or maybe at school or somewhere else. Again, the answers can vary. And to sum it all up, you can say a few words about anything you think should be added. Well, for example, you can mention that even though there are a lot of programmed devices nowadays, this field is still developing, artificial intelligence continues to improve, and there is still a lot left to create. So, it's definitely important to learn this profession. There is still a lot to learn in this area. So, now we can smoothly move on to the idea that when we need to program a robot or some software to perform a task, our job is to write a detailed instruction or a step-by-step procedure for how this program or robot will operate. And accordingly, this sequence of steps or actions is called an algorithm. This is the topic of our first lesson. And to once again bring this information to the forefront, I suggest the students answer the following question. If there were a robot that could make the student's best and favorite sandwich, what sequence of actions would it need to follow? There won't be any answer choices here. I think the students will describe everything in enough detail. The next point I want to emphasize, and you should definitely do this in your first lesson as well, is that mistakes will happen, and that's absolutely normal. You should never get upset, never give up right away, or run to the teacher immediately. When we're working on a task, it's impossible to write a program perfectly on the first try. Only by making mistakes and finding those mistakes will we be able to correct them properly and make our program as comfortable, convenient, and efficient as possible. So it's really important to absolutely emphasize that making mistakes is nothing to be afraid of. You really need to emphasize this strongly, so that students don't run to you with every little mistake, expecting you to tell them exactly how to solve the problem. No, if a mistake happens, the only thing you should do is gently help them find it, and then carefully guide the child toward figuring out how to fix it as needed. So, after we've discussed everything related to this, we move on to the practical part. That is, at this stage, you can already enter Minecraft. And before we start working on the prepared tasks for those children who, for example, haven't attended the masterclass, or those who have only played Minecraft or other games on tablets or phones and haven't used a computer, I sincerely recommend spending about 10 to 15 minutes so that each student can, for example, build a small house. This will help them remember or learn how to control the character and how to open the inventory. This will make it much easier to work on other tasks later, especially those related to programming. Because when a student doesn't know how to control the character or how to place a block, difficulties can arise at this stage, especially if the child is young. So give them 15 minutes, explain to those who need it, and let others just practice. Build a small house, and after that you'll never need to put much emphasis on explaining how to control things again. In other words, you'll have settled that issue. So after the small houses have been built, we open the code editor and explain to the children how this environment basically works. And again, if there were students at the masterclass, suggest that they try to make this program on their own. If a student is here for the first time, then it's necessary to explain in great detail once again how to assemble this program so that later they'll be able to work independently. So it says here that to open the code editor, our task is to press the letter S. Let me show you how to do that. So here we have the main menu. We can create a world. But in our case, we need to join an already existing world. This world, which has been prepared, is available via the link here. So it's easy to download and import it into Minecraft. Great. Let's say, for example, the kids have built their box. Next, we move directly to programming. To open the code builder, press the S or C key in English. And usually for the kids, it looks like this. The first time we haven't entered Microsoft MakeCode yet. We enter it by clicking the very first button. All the programs the kids create will be saved here. At this stage, we're creating a new project. And you can give it a name like algorithm to get the kids used to keeping things organized. In this sense, because later it will be much easier for them to find the necessary parts of the algorithm. That's it, we've created the program. Great. So here I've already explained in detail that the gray area is the workspace. Or rather, I've described it. I'll explain now. The gray area is the workspace. These are all the command elements that we will be assembling. To delete them, you can simply drag and drop them onto the colored tabs. In other words, basically back to where we took them from. And these colored tabs are all the sections grouped accordingly. These are where the command elements are stored, and they are grouped in such a way that it's always easy for us to logically figure out where to find the element we need. So if we're working with an agent, we go to the Agent tab. If we need to do something with mobs, we go to the Mobs tab, and so on. So accordingly, we have the Run button to return to the game, because that's where you can launch all the programs you've written. There are also buttons that let you go one step back or one step forward. In other words, we can undo the actions I just performed. or cancel the undo. There are also zoom buttons. This is especially convenient when the kids are already writing fairly large programs. We can look at them as a whole from a distance. All right, great. And again, I want to point out that if the kids are creating a program for the first time, you should discuss with them in detail what a program looks like and what it consists of. And here I explain that every program, first and foremost, should answer the question when. That is, what needs to happen for this program to start running. Maybe we just need to start the game, meaning that a command will run at the beginning of the game. Or maybe as players, we need to do something, for example, use an item, type something in the chat, just walk or break a grass block and so on. So to answer the question when, and usually all these elements that answer the question when look like a corner piece. I always suggest that the kids program some item for the first time. So if you open the Player tab, there's a command for using an item here. We take this command. As a rule, the kids choose completely different items. Give them this opportunity, for example, to program a bone. And the second important part is, of course, the actual event that will happen when we complete the first step. So, for example, we use our bone or we use our shovel. Again, there are a lot of different actions here, but you can start, for example, by creating some kind of animal. Usually the kids really like this. And for this, we open the Mobs tab and take the Create Animal command. And here, from the drop-down menu, we can choose which animal we want to create. For example, a bee. You don't need to specify the coordinates right now. We'll have plenty of time for that later. Let's go back to the game. Open the chat. Oh, not the chat, the inventory. Take our programmed item, and to use it, simply right-click with your mouse. And that's it. The bee appears. Actually, there are already two. So if this step is clear, let's move on. And again, the first task you need to complete is very simple. But if you discuss it in detail with the kids, then all the others, no matter how difficult, they'll be able to complete entirely on their own. First of all, we show the agent. The agent is the robot executor that we will be programming. It looks like this. The agent's egg, which creates it. Here it is in our last 9th cell. So with this egg, you can only place the agent. There's no other way. It doesn't interact with the egg in any other way. Next, we say that you need to place the agent for the first task on the first strip at the start. To place it facing the right direction, you need to remember that the agent always appears facing the player. So you can move here and place the agent. That's it. Next, you discuss it with the kids. So the agent has a simple task. It needs to go from point A to point B. What does the agent need to do to reach the goal? And here you need to make sure that every student has answered this question so that no one has any difficulties or misunderstandings later on. In other words, each student says that for the agent to reach the goal, it needs to take 8 steps forward. That's it, you've discussed this with them. Open the code builder. Next, you need to use the chat command. This is the most convenient format. Command launch. Here it is under the Player tab with the chat command. You can write absolutely any commands here, even just a number. Kids who, for example, type poorly or don't type at all usually use numbers. So I wrote the name of my command, agent1, and accordingly next I need to write the action so that it moves forward by 8 blocks. Everything related to the agent is located in the Agent tab. Opened it. Next, of course, you can review all these actions. I usually recommend that kids look at them so they don't get confused later. And now, the action we need right now to move forward, we pull it out and drag it right into this corner. Here you can choose the direction. Make sure to show this to the kids as well. But right now we're interested specifically in the forward direction. And then we can control the number of steps here. So in this case we need 8 blocks. That's it, we've written the command, made sure, meaning before we write the command we know exactly what we're going to write, and only then do we open the code creator. It's not like we just start writing something and only then realize what the main task actually is. No, first we discuss everything in detail, show it, and only then do the students write, so that they also have an understanding that first I analyze the situation, understand what I need to do with it, and only then do I start going into the code creator and actually doing something there. We write agent_1 start. To open the chat, it's the letter T, either the English T or the Russian Ya. That's it. We've discussed, analyzed, understood what needs to be done, written the code, launched it, and the agent worked. And after that, the students do everything else on their own. Of course, if any of the students have real difficulties or something is unclear, just come over and talk it through. Let them imagine themselves in the agent's place. Let them draw these mazes on paper, whatever works. But their task now is to complete these assignments independently, to develop algorithmic thinking so that the right approach is already forming in their minds. The right attitude toward the tasks at hand. So it's the same thing here. We place the agent and it needs to go from point A to point B. The algorithm can be completely different. The student's approach to solving tasks is usually entirely individual. Our task right now is to get the agent from point A to point B. Of course, later on, we'll study programs that can navigate the corridors even more efficiently, but for now, even if the program is clumsy, that's fine. Even if there are a lot of unnecessary actions and so on, it's important that the students do it themselves. You absolutely must not impose any particular way of navigating the corridors. Some go forward, then right, then forward again. In other words, they just change direction. Some turn the player. That's it. Let them choose their own path. I've already written out one possible way to complete it here, but that's just for your own reference. And don't tell the kids how they're supposed to do it. Yes, because in the first lesson, the boundaries between student and teacher are set so that you're not the one completing your own tasks, but so that they do it themselves. Their own algorithms, and in general, their own programs. Now, the next parcours is the pumpkin one. It's quite interesting and pretty challenging. Again, the way the kids complete it can be completely different. Some jump right over the pumpkins, some fly around them, some, I don't know, just charge straight through. But that's extremely rare because so far no one has really paid attention to the command to destroy. But if from the start the kids have looked through all the actions available to the agent, then someone might think of it. So again, give them the opportunity to think and complete their own parkour course independently, and only after they've all demonstrated it and you've watched everything, you can tell the kids that the agent actually has a ton of abilities, including the destroy command, which removes obstacles. And it's even more convenient to use a command like this, which allows you to do things on the go, place objects on the go, and destroy obstacles on the go. You can activate this feature by changing the word false to true. False means it's off, true means it's on. That's it. Now the agent can move and break obstacles right as it goes. And in our case, for the agent to go from point A to point B, breaking the pumpkin along the way, it only needs to take 16 steps. So let's go ahead with the agent. That is, at the end, you show the agent's additional capabilities. In the upcoming lessons, the students will, of course, also incorporate all these interesting actions into their own programs whenever they decide it's necessary to use them. That's it. So this is one way to do it. Kids usually enjoy this format of going through corridors, so it's better to show it after they've completed the task. Here, of course, it's a bit more complicated. But there's nothing new that needs to be added here. You still walk, you still turn, and so on. So the kids know that you can change direction, you can go up, you can go sideways, however they want, really. And this corridor, as a rule, raises the most questions, because there are quite a lot of blocks there. And this is exactly where the kids start having difficulties. Don't rush to help them. Let them once again try to find the solution and run the agent several times. They should see where it makes a mistake and fix it themselves. Once they've made it through this corridor, the final task is for you to explain to them the difference between relative and absolute coordinates. Of course, we'll discuss this in more detail later, but at this point in time, draw their attention to the fact that the agent can teleport to a specific point. But since these are relative coordinates, meaning they're tied to the player, we need to change them to world coordinates. And then replace those zeros with the point where we want to teleport. And here it is, the fifth task. We need to teleport the agent right to the center of this square. What do we need to do? Of course, someone will want to do it this way, just with an agent, or install the agent themselves, but still no, because it is very important now to pay attention to how the teleportation command works. In the center of this square, the coordinates are 72, 4, minus 13. 72, 4, minus 13. And accordingly, we write here 72, 4, minus 13. And the direction, so we have x, which can be positive or negative, and z, which can also be positive or negative. But right now, we need the agent to be facing in the negative x direction, so that it's looking roughly in this direction. Let's go ahead and run it now. There we go, it teleported and is now facing in the negative x direction. We'll figure out how to determine the direction later. For now, for example, you can just try changing it randomly and see that every time we change the direction, the agent looks in a different direction. Just like that. Great. When all these tasks are completed, the students will have fully practiced the skill of writing their own algorithms. You can sum up a bit, ask questions, for example, what is a program? I think they'll be able to answer that a program is a written list of actions. It's a list of actions for robots. Of course, they answer differently, so give them a chance to formulate it themselves. What is an algorithm? It's a sequence of actions that leads to solving a certain problem. What does the command destroy obstacles mean? False? Here, pay attention to the fact that you need to clarify that we can either enable or disable displacement on the go, or the destruction of obstacles on the go, and so on. And of course, note that the agent can move in all directions. This will be useful for them in their homework. And for the homework, they need to write a dance for the agent. That is, to write some kind of algorithm, a sequence of steps, so that its movements resemble some kind of dance, like it goes left, right, forward, up, spins around, I don't know, whatever you want. And once you discuss these tasks, basically the lesson can be considered successfully completed. Make sure the kids didn't have any difficulties and get them ready for the next lesson, where the agent will already be building various elements, which will of course eventually lead us to the point where the agent can build entire houses and so on. Thank you for your attention and see you at the next lesson. Bye-bye.